Hello, I'm back with another demo. From the Steam Next Fest. This is Hard Chip, a programming puzzle game about designing computer components, kind of like Turing Complete. But the difference is that you're creating chips from transistors rather than abstract logic gates. WASD, move around, look around, center camera. Hopefully many of these will be taught. Definitely beta, somewhat limited content it sounds like, but we'll see how much content there is. There is a sandbox apparently. So I might get stuck in that. But this looks like something that I could really enjoy. Let's see. Starts with a bit of a 3D section. Not sure that's really necessary, but... General failure, I/O error, device not responding, network timeout, memory overflow, power surge, damage to components likely. Hello, from an unknown error code. Critical failure, system reboot needed. There should probably be more explanation there, but help works. Help often works. Status. Physical integrity and control systems still work. Power is not, though. Reboot. Generator offline. This is the autonomous generator thing, I guess. No connection to power grid, but we have some amount of power now. That's cool. Mouse sensitivity now is a bit high at the moment for me. Often the case. It's fine. So now I can move over there, I guess. Seems to be the only other thing on. From question marks, trust in the guidance I offer, for my only aim is to lead you to clarity and resolution. Safety door failed last ping check. Status. Adder chip damaged. So yes, the 4-bit adder is the limit of the demo, apparently. Reboot probably won't work. Good try, but... Workstation. Received requirements, ready to start. Help. Start it is. No database, but we have a fabricator. Not NAND and or XOR, bit full adder, 4-bit adder. Cool. Let's design it. One in, one out. I'm only here to help. Trust in the guidance I offer, for my only aim is to lead you to clarity and resolution. This one block is a substrate block. See it as the support for everything else. This is the die, composed of the entire set of all blocks. It's an input block. It provides signal to the die to process it. And that is output. It receives the signal. Just pass through here. Connect the input and output, use a trace block, and click. Then validate. get hints and help from question mark. Okay. So with a trace, click. How does this work? Add one block with left click, add a line, hold and drag. Okay. Why is that not working for me? Oh. Can go through the substrate is why. Alright. Takes some amount of time to propagate through each block. No way to do better, possible to do worse, but complex, satisfactory, efficient number of blocks. Onwards, control. Click Miha. Trace input and output blocks can have 3 states. On in red, off in blue, 1, 0, neutral in gray. Input blocks cede 1 or 0 states to adjacent trace blocks, otherwise all blocks will revert to the natural neutral state, controlled by the validation process, but I can test by clicking. Stop the validation. Click there, huh? On, off, on. Aha. And it propagates backwards. If I turn it back to off, what if I make it on? And then do that. The red overpowers things. Interesting. How does that work then? How do they decide? It's the output block that changes? The output block sticks and is a control, I guess? How would it work in real life? You change the voltage at one side, current starts flowing, stops flowing. It depends on what the output bit means. I guess you look at it as connect it to ground and measure if there's current flowing or not. So it's high voltage, I move it to low. The change propagates along there. Why it chooses to go back? I can dance and keep a neutral section. But the output is somewhat solid. I guess when it's high, it pushes the negative out towards the output, and when it's low, it pulls it back in. Or, kinda. Interesting. It's not purely local. Which doesn't entirely sit right with me, but... Conflict. Connecting two inputs with opposite states results in a short circuit. Right, this is connected to low voltage, that's connected to high voltage. We get a ton of current flowing through because this is a low resistance path. Alt-click to remove a trace. Oh, and if I put it there, yeah. Short circuit. Cool. If I leave that in and validate, I get 11. So yes, you can do better. Compliance. Now we have tests. Connect A to A, B to B. Some validation requires multiple steps. Each step has its own requirements, each verified in order, one after another. By clicking on the side rather than the middle, I can go drag easier. That looks like self-promotion. Let's validate. On, then off, on. So, make it blue, red. I still am confused on how the simulation works. But okay. I get the basic ideas, and if I don't do strange stuff, it'll all work. Crossing states. To isolate traces from each other, they must have at least one empty space between them in any direction. A connected to output A, but not B or C. Add traces on top by pointing at the center and moving the mouse up. A down to A, B across, C across, I guess. Let me go over here. Ha ha ha! Yeah, we're not playing Trackmania anymore. I did warn you I don't just do Trackmania. This is a puzzle game called Hardchip, and it's about computer engineering, kind of, I think. B connected to B, C connected to C. I don't... Is there a better way of... No, because it's flipping, so C's gonna have to go over both B and A. If I take it only up one, then out to the side, those connect, yes. So I take it up 4, I suppose, go over, and this way, and there, and then I can do a little bit of cleanup here. And that should work. Now there is a way to do it in fewer blocks. 43. I thought there might be. Let me try that. So we need this to not go up so high, which means this, the A, has to be down earlier. Or in the middle. Or B could go up. Let me delete those, that. So if B goes up, here, and then over, and down. Then can we fit A and C swapping in between? That is the question I'm thinking of. So A can go over here. Where then C can do what? Ah, well, A can come up 1, 2. Yeah, but not there. Is there? How is there room to do this? We could go over to the side. That's not very efficient, though. Well, removing 4. 1, 2, 3, 4. So we do have one more up and down section, is how this works. Or a zigzag somewhere, maybe? Not there. Here, up, up. C comes out, over this way, and up to there. But then we can't get A through. Okay. So if instead I take C, not quite that far. One, 2, 3, 4, 5, 6, 7 times 3, 21. Plus 1, 2, 3, 4. Yeah, plus 8, so 29. We're looking at an extra 43, so 14. Which means up and down 7 each. What? Was my first try really not good enough? Go here, go up. Go over this. A side comes over here. Oh, this might work. Go up here. Oh, too early. Yes, too early. Here, go up from here. Up 2. Then A comes through here. Over there. Just extend the lower level section longer to use fewer overhead blocks. The overhead blocks shouldn't cost more than the non-overhead blocks, though. I think, anyways. It's just how often you go up and down, is my understanding anyways, but might be wrong. That's 43. There we go. Why is that 43? I go up 2, down 2, up 2, down 2. That's 4 each. And I must have miscalculated 1, 2, 3, 4. 1, 2, 3, 4. Oh, is it the 6 extra there? Yeah. Right, so we count the input and output blocks. Is the 6 I was off. Yeah, cool. So that's 43. Cool. Bonus. Across the wall. Traces can be tricky to place without touching each other. Connect input and output without short-circuiting. So I think this gap is most promising. Indeed. That's going to be the only way through. Take it out this way, and across this way. And then up, just 2 should be enough. Camera's a bit weird. Across that way. Oops. Up from here. There we go. And then in. Yay! Unlocks the next section. Now we aren't just connecting wires. This is where it gets interesting. Traces can only transfer one state at a time, but MOSFETs, metal oxide semiconductors, field effect transistor, can react to states. Here's a MOSFET, or just MOS. Okay. MOS has 2 major parts, the gate and the channel. This one is a PMOS. Positive. Acts like a switch, can be activated or deactivated. Applying 0 to the gate's PMOS activates it, allowing only one going through it. Applying 1 deactivates it, blocking all state going through it. Connect the PMOS properly, then validate. Okay. Positive metal oxide semiconductor. The gate, the channel. Only one side of the gate needs to be connected. Both sides of the channel connected. So when that's 0, then the gate is open, and a high voltage applied to one side carries over to the other side. A low voltage applied to one side does not. When it's in 1, the gate is blocked, nothing passes. Just assuming command means apply that to the gate. Oh, is it actually... Yeah, it has to be up 1, huh? Sure. Then apply the signal here. 1 goes through. There we go. If I apply instead low, it doesn't pass through. But 1 can. Instead apply a 1, the gate is blocked, Okay. Interesting. It's possible to do with fewer, huh? Looks like 26 blocks? How's that? Ah, probably by getting rid of that section, going up here, and across to the gate. Yeah, because you can connect to the gate from there. Alright, good to know. Onwards. And the alter ego, the NMOS. Exact opposite. Blue strips differentiate applying a 1 allows 0 through. 0 deactivates it. Right, so they allow the opposite through. The opposite polarity allows... yeah, okay. Got it, I guess. And those are particular arrangements of semiconductors that you put down on printed, not a printed circuit board, on silicon. And that's what a computer chip is. A whole bunch of those. Bonus, the merger. MOS can take different shapes, not just 3x2x3 blocks. Special shape MOS can have 2 gates and share the same channel. Merge PMOS with 2 gates. Okay. Ah, like so? Ah, okay. Got it, I guess? That's now blocked. That's blocked. That's negative. Not sure why that's staying positive, but whatever. So I can join them up like so. Can I join them other ways? Well, apparently it's possible to use many fewer blocks. How would that go? Can I move? I can delete. Oh, I can move gates around. That's interesting. Don't have traces. I just have... or no, that's a third one? What? Oh, I can remove some of those bits and, remove the extra bits of gate. No? Oh no, that's short-circuiting now. Why? Why doesn't that work? Let me erase the level, refresh those. That should be working. And then if I remove these blocks, still works. It's unresponsive. They're supposed to both be open, but the channel's not working. Okay. Got it. Erase. So you do need these corner bits? I'm confused. How do you do this in fewer blocks? If I remove that, no. It wants to have both sides of the gate. Moving that doesn't work either. That blocks it, that blocks it. So we start here, then we turn both gates to block. That's off. Turn both gates on. Ah, they're kind of cheesing it. And when these are not activated, it's open. That's also surprising, but okay. Well, in that case, I should, since the A and B are always doing the same thing, no, no, because the only blocks I have are given here. Like that just stops. Yeah, I don't have traces this time. No, but I could do this, and that might cheese it. It does. Okay, maybe they should improve that test. Anyways, next section, schematic and compacting, building the inverter, huh? Most of the time, schematic are available with the chip icon. It provides optional steps to build the chip for each level. Use the schematic or not to build an inverter, then validate. Inverts the input. Here we have 1 and 0 provided as constants. Ah, yes. So this is an explanation of how you can build the thing. Resize, move, do a PMOS and an NMOS. Both gates connected to the input so that with the PMOS, it only allows 1 through on 0, and the other one allows 0 through on 1. And I guess you can't place these higher up. No, do not appear to be able to, which is probably sensible. I guess that trace is going to be there, probably. Can I rotate? I can rotate. How about other controls? Can't tell. But we have a PMOS. If I put a trace here, it's just going to connect. So can't do that. Control Z does not work. Yeah, let me put it down here. And an NMOS. here, I suppose. These are aligned there. Got the camera in a bit of an odd position. Help. Copy, cut, paste, delete, remove readouts. Sure. No. Camera needs some work. Can't even move. Yeah, I can't move any farther forward than this. What if I erase the level and do actually exit and re-enter? I guess the gates connecting is actually a good thing. So move this over here. Connect it there. This one I have to take out a little, I think. Don't want that connection. Here, oops. Get rid of that, bring this up higher. This through here. Up and over, and that's red, or on. Then a block here, connecting to the gates, and we connect these bits up to the output. Is there ever a problem with short-circuiting there? I don't know. Can also do it with fewer blocks, but I'm gonna skip that for now. Compacting the inverter. If you need more space, just build outside the die to extend it. When you validate, any empty contiguous spaces will automatically be shrunk. Doing so will shift any output to the new edge location. Info, full report unlocked. Compact and optimize the inverter, then validate. Okay. Compact to 9 by 9 or less. Hit validate, that's supposed to be the output. Reset. Build outside here and over there. That works. Footprint satisfactory. I should modify that. Can I move these? Validate? No, not really. Okay. In that case, how to do this? Kind of want the output on that side, but then getting input is hard. Kind of. Well, yeah, I guess it reduces the footprint slightly. Traces there. This up. It also just looks cleaner. Here we go. Out and over. Exact routing doesn't matter too much. Because, yeah, I don't think I can change the height of that. Might be possible, but... it's pretty good on blocks. About footprint. Now, still possible to take it down further. 7 by 9 by 5. It does feel like I should be able to go down. Size of the die, expand, auto shrink on validate. Yeah, only removes empty row and column. So, not really. Oh, I can shrink it one more here. If I make this closer. Oops, wrong way. Rotate. There. That should be significant. Trace up here. And pull that through. Why does that do a short circuit? This bit should not be on. But it is. Is this no longer working? This should be a PMOS there. Yeah, no, I can't actually squish the two PMOSs together like that. Okay. There's no trash option, unfortunately, at the moment. So what if I do try different orientation? Have the gates lined up like so. No, I don't really like that. They could share the channel, but it needs a place to get out. Oh, I can adjust the dimensions with just building off here? No? Doesn't like that, huh? Should be able to build off the edge in any direction, but can't actually. Okay, that's annoying. So then I can't really adjust the positioning of that input. Building up from here? Oh, building up from there doesn't connect to the gate. Oh. Does building there do anything? That also works. Okay. Okay. P and N, because N can't be there. Go like so. Do traces. Can I go across there? Doesn't appear to be so. Has to be some amount of separation. This is still not bad. This goes out to, I guess, then over. This comes up, that comes up. Oh, that's an awkward bit. Ah, so I swap them. That's what I do. There and there, don't need those, don't need that. This comes up, this comes over. That is quite clean. If it worked. Why doesn't that work? That allows red through. That doesn't allow blue through. Okay, I guess that connection's just not working. It should. Reset. And maybe it doesn't like the gate combined with the input block. That's reasonable, I suppose. Shift it all over. Oh no, were those connected? No, that was the gates. Which, oh, the gates were probably connected to that? No, not really. Put that there, that, wrong orientation. That there, that there. Through here. And up here. And then this going over to the output. How does that work? Oh, well, I need to connect to the gate. Like so. And they're both the same kind, which is wrong. So that works. Cool. Still not great on anything, but good enough for now. Intro compact inverter. Save selection, save all, blueprint library. Use, edit, duplicate, rename, delete. Schematics. Okay. Save blueprint. Have I saved it twice? No. Exiting, confirm, yes. Okay. NAND gate. Schematic. Couple PMOSs, couple NMOSs. So what does this look like? we can choose positive when either one is off. So that's, I'm surprised that's not 3 NMOSs, but, or 3 PMOSs. Because you should be able to do it with the PMOS connected. Oh no, they're going to be active on 0, right? So what this does is NMOS gates, if both A and B are off, or if they're both on, then output is connected to negative. If either one is off, we connect to positive. Makes sense. Edit blueprints, readout toolbox, saves, race level ticks, a bunch of stuff over there I haven't been paying attention to. Rotate, zoom, strafe, okay, yep. So, how to lay this out? We need 2 NMOSs with the channel in a line. Can go like that for a combined one. And then 2 PMOSs like so-ish. Now trace. We need P from here over here-ish. Like so works. These are connected to the gates separately. Here, negative should be connected to those traces, while these should be connected to both gates. Yeah. What if I go free cam? No. Nope. Sure. Oh. That's better. So there's one gate connection. We can take this up and over like so works. That's 2. We need negative connecting to that trace. Not like so. That works. And then A and B connecting to these 2 gates. What does that mean for this? Oh, so this trace goes through here. That's the output. want that connection, but take this up one more, and that should work. Connect that through there, then I just need connecting to that gate. Sure. Like so. It's an AND gate. Not bad on ticks. Not bad on footprint. Apparently possible to do better. Blocks and everything. Save. Sure. Card chip demo checked. Demo completed successfully. Oh, I thought the 4-bit adder would be part of the demo, but it's not. Okay, that's fine. Now, I was told that there is a sandbox. How do I get to the sandbox? Can I? Perhaps not. That went off screen. Edit blueprints, readout toolbox, auto shrink on validate. Edit die size. Edit die size would let me change those things, I guess. Cool, that's nice. Import from clipboard, level, export, traces groups. Color with the same color. Okay. Auto clock stop. Change indicators. Interesting. Readouts. Different positions. My blueprints. Save all, blueprint library, edit. Got it. So this might be the end of the demo. Feels very interesting. Be interested to see where it goes. Thanks for watching. I'll be back with something different next, I assume.